Hello and welcome to Algebra 2, Chapter 6.2, and today we are embarking into evaluating and graphing polynomial functions. So we're first going to talk about evaluating a polynomial function, and in order to do that we need to talk about the general form of any polynomial function, and it is f of x equals a sub n x to the nth power plus a sub n minus 1, x to the n minus 1 power, etc., all the way until you get to a sub 1, x, and that would be x to the first power, plus a sub 0. And so what we get this pattern here. So for instance, if this was, let's just say a sub 4, it'd be x to the fourth, plus a sub 3, x cubed, plus a sub 2, x squared, a sub 1, it is x to the first, and then a sub 0 is also x to the 0, but remember that anything to the 0 power is just 1, so a sub 0 times 1, that's what makes that just be a sub 0, and we don't typically write that 1 there as your exponent. So that's how we get this equation. All of your a's would be numbers. Okay, so but it's just we use that subscript to denote that it goes to that term. A sub n cannot be 0. Okay, so that leading coefficient can't be 0. All of your exponents have to be whole numbers, and so remember whole numbers are 0, 1, 2, etc. And all of your coefficients have to be real numbers. So we're not going to have any imaginary numbers as coefficients here or as exponents because that's not a whole number. Okay. A sub n is your leading coefficient. So this number out front is your leading coefficient. Okay. And the degree on that first term is the degree of the entire polynomial. So if our example up here, for instance, that would have a degree 4. That was a 4. All right, and so standard form is written so that your exponents are in descending order. So notice up here we had 4, 3, 2, 1, 0. That would be our descending order. So here are a few polynomial functions that we've talked about before. The first three we've actually talked about before. F of x equals a sub 0 is a constant function. Lots of times you just might see y equals 3. That's just a constant function. It has a degree of 0, okay, and that's because you would put an x to the 0 on there. A linear function, you might see it as y equals 3x plus 4. Okay, there's a linear function has a degree of 1 because that leading term has a degree of 1. Quadratic, y equals 3x squared plus 4x plus 7. There's a quadratic that has a degree of 2. So a cubic is just going to mean you have an x cubed as your highest degree, and a quartic is going to mean that we have an x to the fourth with our highest degree. So we're going to decide whether these are polynomial functions or not, and if it is, we're going to write it in standard form. So the first one, f of x equals 2x squared minus x to the negative 2 power, is that a polynomial function? No. Why not? Because your exponent is not a whole number, okay? And it doesn't ask us why not, but we'll write it anyway because exponent is negative. And then when you go back later and look at your notes, it's in there. So is the second one a polynomial function? It is. And if you recall back, are all of your exponents whole numbers? Okay, we've got 4, 3, and 0. Those are all whole numbers. Are all your coefficients real numbers? You got negative 0.8, 1, and negative 5. They are all real numbers. So yes, this is. We need to write it in standard form, which is decreasing in terms of our exponents. So you're going to write x to the fourth minus 0.8x cubed minus 5. So there's my function in standard form. Its degree is 4. There you go, degree of 4. Its type It is a quartic. And the leading coefficient is 1, because it is 1x to the 4th. So the next thing we're going to talk about is evaluating functions. And there's two ways that we can evaluate. Direct substitution is what you're used to, and that is just you plug in x and simplify. So if somebody says, evaluate 3x squared plus 4x minus 7, 4x equals 2, you just plug 2 in for both of those x's and then just use your order of operations and simplify. So something you've been doing for a long time. So we're actually going to concentrate then on something called synthetic substitution, and it's a process that only uses the coefficients and then of the terms and the number you are evaluating for to determine the evaluated value. Okay, so we're going to use the coefficients and the number we're evaluating for, which could be like x equals 2. And we're going to do a process that we're going to call drop your mama. Okay. All right, so here's how we do synthetic substitution. Is you have to write out all of your coefficients, and we need to account for every single x degree. So our leading degree here is x to the 5th. So I'm just going to make myself a little note here. X to the 5th. I'm going to account for x to the 4th, x cubed, x squared, x to the 1st, and x to the 0. And you wouldn't necessarily have to write those down, but I'm just going to make a list there so that you see where I'm getting these numbers from. So I need the coefficient on x to the 5th, and it is 3. And the coefficient on x to the 4th, it's negative 1. Coefficient on x cubed is 0, okay? These are called missing terms, and a missing term is just an exponent that you're missing. And you have to account for these here, okay? X squared also has 0. X to the 1st is a negative 5, and x to the 0, which is your constant, is a 10. So you write out all your coefficients, and then we're going to draw this L around them, and you need to leave enough space on the bottom row for another row of numbers in there. And we're going to put the negative 2 on the outside, because I'm dividing all of this by negative 2, or I'm actually evaluating. Okay, so here's where the drop your mama comes in. So the first thing you're going to do is drop. So the 3 drops down. And then mama stands for multiply, add, and we're going to do it as often as we need to. So we're going to multiply, and you're always multiplying by this negative 2. So if negative 2 times 3, we put it up here, is negative 6, and then we add these together and we get negative 7. Then we multiply again and put it up here. You're always multiplying by that negative 2, so you get 14. You add is 14. Multiply, you get negative 28. Add, you get negative 28. Multiply, we get a positive 56. Add, you get a positive 51. Multiply, you get a negative 102. Add, you get a negative 92. Okay, this last number is your answer. So we could write f of negative 2 equals negative 92. Okay. Even if you think regular substitution is easier, faster, you are going to have to do synthetic substitution later on for some different things, so you do need to know how to do it. So let's do another example. All right, so we're going to start out by writing all of our coefficients. So in this case, we're going to start with x cubed. So there's my x cubed. X squared has a coefficient of 1. x has a coefficient of -4, and my constant is 1. So this time I had no missing terms because it went x cubed, x squared, x to the 0. You're going to draw in your L around it, and you're going to put your 4 on the outside. And we start by dropping, so the 5 comes down. Then we multiply and get 20, add and get 21, multiply and get 84, add and get 80, multiply and get 320, add and get 321. Okay, I don't want to work out this word problem just for the sake of time, but just to show you, to disarm a business security panel, you must push a 4-digit button, and it tells us that the total number of ways to set the system is modeled by this function here, and B is the number of buttons. How many ways can the system be set if there are 12 buttons? So this is really just a plug 12 in for B kind of problem, and so I would hope that you could do this with your synthetic substitution or synthetic evaluation, and do the same thing we did on the previous two examples, but just put a 12 on the outside, and then the inside it looks like would be 1, -6, 11, and -6. So you might see if you can do that, and you can always do your regular substitution to check it. So the next thing we want to talk about is graphing a polynomial function. And a key thing when you're graphing a polynomial function is what is the end behavior going to be? And so there's two ends to these. And so the question is, what does the graph do as x goes to positive infinity? And what does the graph do as x goes to negative infinity? So just as a quick example, we spent some time graphing parabolas. So if this was my parabola, as x goes to negative infinity, what is my parabola going to do? My parabola is going to go to positive infinity, because that would be going up to positive infinity. So you would say as x goes to or approaches negative infinity, f of x, which is your graph, is approaching positive infinity. And then on the other side, as x goes to positive infinity, what's my graph doing? It's also going to positive infinity. So you're going to have two answers for these. And you always start out with as x does, then f of x, in this case, they both go to positive infinity. So the deal is that based on the degree and the leading coefficient, that you can always know what your end behavior is going to be. And it really boils down to this term is going to dominate the rest of the terms. Okay? So if all the x's are the same, this x to this higher power is so much bigger than the other x's that you can kind of totally ignore your other x's. And so if n is even, then it will turn any number positive, but if a is negative, then you're going to get a negative. So here we go. If n is even, which is the first one and the last one, or the first one and the third one, if n is even, because it turns any number positive, if I multiply by an a that's positive, here's an a that's positive, then what I'm going to get is as we go to negative infinity on the x, f of x goes to positive infinity, and as x goes to positive infinity, f of x goes to positive infinity. So they both go up, which is like the parabola I just showed you. Now, if I multiply by a negative leading coefficient, they're both going to go down, okay? Because that's what your negative a does at the beginning, is it turns it upside down. So if n is odd, if I put an even number into an odd, or actually let me see, if I put a positive number into an odd, it's going to say positive, but if I put a negative number in, it's going to go negative. So let's see here. For these other two, if n is odd and the leading coefficient is positive, then our graph is going to go to negative infinity as x goes to negative infinity. So that's going to go like this. And it's going to go to positive infinity as x goes to positive infinity. So you might do something like that. So your ends are going to be split. So here we had something like this or something like this. Okay. And the last one, if a is negative and n is odd, your graph is, as x goes to negative infinity, your graph's going to go to positive infinity. And as x goes to positive infinity, your graph goes to negative infinity. Okay, so really what this boils down to is you need to write down this list. And we can definitely go over some more in class about trying to figure out when it's one way versus the other. So we're going to do one example here on graphing. And to start out with, so if I have an odd degree, okay, so this would be the second one and the fourth one, and I have a positive leading coefficient, because that's a positive 1 there, I'm looking at something that goes down as we go to negative infinity, and it's going to go up as we go to positive infinity. So the question really needs to be is what happens in the middle, because lots of things could happen. Okay, so how do you graph anything? You use a table, and we need to plot enough points that we know where this is. So I would probably start with 0. If you put 0 in for x, you're going to get 3. Okay, and then it's just really trying to figure out what x's you need. So if I put in a 1 for x, and I'm going to go ahead and set up my calculator to do these for me. So if I put in a 1 for x, I get 5. Okay. So what happens now if I put in a 2 for x? Let's see. If I put in a 2 for x, I'm at 17, which I'm not going to graph that one. So let me come back the other way and put in a negative 1. At negative 1, I'm also at 5. Which might make you think of a parabola, but is this going to be a parabola? This shouldn't be a parabola because it's not a quadratic. So let's put in negative 2. At negative 2, I'm also at 5. Okay, well what happens between those? And this is really why I plot as I go, because, that's interesting. So let's do negative 1.5. I get 5.625. So halfway between there, we came up to around there. All right. Negative 3. Negative 3 is negative 3. All right. Let's just see what negative 4 gives us. Negative 4 gives us negative 25. Okay. So here you can see as x increased, my f of x started going to positive infinity, and as x went to negative infinity, you can see that we went to negative infinity there. So when I draw this in, it's going to come down, turn, and go, I didn't plot one of them, did I? I should go through right there. Okay, there you go. So that is what a cubic looks like when it's graphed. All right. Make sure you write down any questions you have. Make sure you take good notes. And so if you need to go back and write anything down, that would be great. And I will see you in class next time.